This is another DocWatt, Texas quick video. In this video we're going to review briefly the idea of ranking data. We're going to focus on the ZScore, but just as a review, if you're watching this video, then I'm assuming that you've already studied the absolute ranking of the data. That means just putting it in order, possibly the lowest to the highest as an example. The problem with that is that there's a whole lot of difference in saying that you're third place out of 1,000 and saying you're third place out of 3. So the idea of relative rankings is often used. With percentiles, we talked about something like the 25th percentile. Sometimes we use notation like this, P with the 25 down there. So we're looking for a particular number so that 25% of all the scores are below that number and 75% of the scores are above that number. There are different ways that percentiles are calculated, and sometimes one piece of software will actually come up with a different answer than another piece of software. And another related way of doing relative rankings are called quartiles. So we talk about the first quartile, the second quartile, and the third quartile. For us, these mean the same thing as the 25th percentile is the first quartile, the 50th percentile is the second quartile. Now, and of course that's the same as the median. And the third quartile is the same as the 75th percentile. Third quartile then, 75% of the scores would be below that amount and 25% would be above that amount. Okay, we're going to look at another kind of ranking here. It's called the ZScore. This is what the thing that we hope to understand today. As ZScore, you're able to rank data with a ZScore if you happen to know the mean and the standard deviation of either the sample or the population. In the case that we're talking about a sample, then we use the symbol X bar to represent the mean. We use the symbol small letter s to represent the standard deviation. If we're talking about a population, we use the Greek letter mu to represent the mean of the population. We use the Greek letter sigma, lowercase sigma, to represent the standard deviation. Now what the Z-score does is tell you how many standard deviations a score is away from the mean. So the Z-score is calculated in the following way. Z is equal to the particular score you're looking at minus the mean, in the case of a sample, the sample mean, divided by the standard deviation. Now let's look at what that means. If x is larger than the mean, then this part on top will be positive. So positive z-scores mean that we're above the mean. And of course you're going to see how far you are above the mean and then divide by the standard deviations. So the z-score is telling you how many standard deviations you are above the mean, or if x is smaller than the mean, then this value will be negative. A negative z-value tells you that you're below the mean, and the z-score tells you how many standard deviations you are below the mean. So of course if you have population data, then that formula just becomes z is equal to the particular score you're looking at minus the mean of the population divided by the standard deviation. Okay, so that's how z-scores are used to help tell the ranking of a particular value. Okay, that's the end of this DocWatt, Texas quick video.